Okay, dears, this is the time for block diagram reduction technique now. The meaning of a block diagram reduction is when the system is having multiple blocks, we are going to reduce these blocks to be one only. Means we are having here a block, another block, another block, maybe here there is another block. However complicated is the system, we are going to come out with one block only representing all these elements. I mean, instead of having this complicated kind of a blocks, we are going to express it as one block with input, transfer function, and output. Later, when we apply the theory of control system, we want the system to be as one block to be able to deal with it. If you look at this system, for example, because we have studied it earlier, this is a block, we call it forward transfer function, feedback transfer function. So I can say it's multiple of a block. We can reduce it to be only one block with input and output. And how it's going to be done? Because here we are having a closed loop system. So whatever method we have studied to simplify the closed loop system, we will result in one equation, and the equation is going to be placed here. We will see this after a while. So the block diagram will be block, which representing the system, input, which is the signal, and output, which is the signal. So arrow, usually it's a signal. We will expect, or we expect to see in the block diagram a summing junction, where in the summing junction we have a few inputs, and the output will be the total of the inputs, considering the sign given. Now, pick-off point, also another shape can be found, or another form can be found. In pick-off system, the outputs are going to have the same signal as the input. So it seems to me like the input going to be will be distributed to three other elements as I'm showing here. More forms will be found on the block diagram of a control system, like cascade. Cascade means what? Means we are having a system with signal going to a block. The output of the block will go to another system and to other block, and the output of the second system will be a signal which will go to a third system or a third block, and this is the final output. And instead of having them cascaded as a one after the other, we are going to reduce this arrangement to be in one block. So what will be the result of this block is going to be the product of the three blocks. Like if this is G1, this is G2, this is G3, we are going to put here G1 multiplied G2 multiplied G3 as I'm showing here. We may find also parallel form. Parallel form means what? Means the signal are going to be connected to a summing junction. We call this arrangement parallel form. So how am I going to simplify these elements? How am I going to simplify this? You see, I have to consider the input. This is the input. Here is the input. Here is the output. In between will be in one block. What to put in that block? We are going to see how the relation is going to be here. This signal is G1, where here I'm going to get RS into G1. RS into G1 will be found here. Here RS into G2. Here RS into G3. So what I will find on the output? G1 plus G2 plus G3 into RS. So we can put it like this. RS is here. We put here G1 plus G2 plus G3. That means CS is equal to G1 plus G2 plus G3 into RS, similar to this. So whenever we have a blocks connected through signal to a summing junction, the result will be, or we can simplify them as finding the total of those blocks. We call this parallel. Feedback, that's what I mentioned just now, which we have studied earlier. Whenever I have feedback, it can be simplified as one block by considering the equation we studied long time ago, the equation we studied at the beginning of the semester. If I consider this system, we have here cascade. So we can simplify these two blocks as a one block. These two blocks here as one block. Now I came to the point where it's to be simplified, these things all to be simplified to one block, which is going to be this one. So I assume that, or not I assume, I find that this is the output and this is the input. In between them, what do I have? It's a feedback system. Feedback system, I hope you remember it. We will find that the transfer function can be written as GS, which is the feed forward, over 1 opposite sign, I hope you remember, plus minus, to feed forward into feedback. That's how we can simplify it. So instead of having this arrangement, we can simplify it to be this block. Sometimes we are allowed to move the block from its location to other location, but we have to keep its effect. Like here, for example, if I have this arrangement, RS, XS, summing junction, and here we have GS. If for any reason I don't want GS to be here, I want to remove it from here, that's going to make the things easier for me. If I want to remove it, it's in the output. I can send it to the input. But the theory is saying, if you want to take it from here to one of the input, you have to send the same thing to all other inputs. So the equivalent of what you can see here, the equivalent of this one is this one. That means whenever I have summing junction, its output has a block, and you want to remove this block from here, put it on all the other inputs. That's why we put it here and here. Okay, let us look at the other side, the other one. What if I want to do it the other way around? Means I have a block at the input of the summing junction, and I want to remove it from here. Where to remove it? It's going to be sent to the output. So from input, I will move it to the output. Can I move it and that's it? He's saying no. If you want to move it to the output, no problem. Put it at the output. But keep in your mind that you have to put its reciprocal to all other inputs. I will repeat. I'm having a block of GS. I want to send it to CS. So I put it here. It's okay, I put it here. But in the same time, to keep its effect, I have to put its reciprocal, means 1 over GS, to other inputs. Another movement, that's movement of the summing junction. Here is the movement of pickoff. How about the movement of pickoff? He said, if you have a block at the output of pickoff point and you want to send it to the input, you can do it, no problem, but put the reciprocal to all other output. This one, take it from here to the input, no problem, but as you see here it becomes empty, but I put it here. In the same time, I have to put the reciprocal of the block to all the other outputs. G1 is a block on the output of pickoff point. When I move it to the input, it's coming here, it becomes GS, not G1, GS. So other output, these outputs are going to be with 1 over GS and 1 over GS. If I want to, now I'll come to this rule. If I want to reflect the block from the input of pickoff point to the output, simply give it to all the outputs, and that's it. Once you decide to take it from here to the input, you can, no problem, but keep in your mind that all the other outputs must take the same value. Why we are doing it this way? Why in reflection we are considering it this way? Because we need to keep the mathematical equivalent of the block. We should not disturb the mathematical equivalent. We should not disturb the mathematical equivalent of the block after and before the movement. So whenever I move the block from location to other location, the values of the output supposed to be maintained the same. That's why we used to follow these rules. Let us look at this example to see what we mean by moving the blocks or finding the cascade or parallel or whatever. Let us see it here. So here he's saying reduce the block diagram shown to a single transfer function. So out of this all, I will get one transfer function. What is that transfer function? It's going to be assumed as this is the input, which RS. where this is the output is CS. In between here, all of this will be one transfer function. We will add them. We will find a way to solve, to reduce them. How am I going to reduce them? Let us see in the next slide. So the first thing I will do is removing the 3 summing junction, because they have, there is no point to keep them as a 3. The summing junction, one after the other, like one summing junction, another summing junction, another summing junction here. If one is giving the other, and here signal coming, here signal coming, here signal coming, actually no point to keep them as a 3. We can keep them like this. So we will join all the summing junction to be only one summing junction. That's one, or the first thing I will do. Here I did nothing. There is no rules there. No rules. It's just a summing junction. We put it as a 1 unit, because finally it's just adding. We will add the signals together. Whether you add them 1 plus 2, then the result will be added to 3. The result added to 4. We can do them all one shot, 1 plus 2 plus 3 plus 4. So this is done. Now, if you look at this arrangement, let me just put it in a circle. This arrangement, it's very clear that we are having signal, this signal entering, this signal entering 2, 3 blocks, and the result is going to the same summing junction. This is parallel. This is parallel, dears. That means we can take whatever inside this green circle I am putting, we can put them as H1 plus H2 plus H3. We can add them, but keep the sign. Please consider the sign. So we are going to put it as, notice here, H1, we put it H1 minus H2 minus H2Y, I will tell you after a while, minus plus H3. If you want to check why we are putting the signs like this, look here. This is, if you consider it like this, is going to be minus this minus H1 plus H2 minus H3, right? Minus H1 plus H2 minus H3. But if I put the sign here negative, that means the signs inside the block must be the other way around. So this is a plus, minus, a plus. When they are going to this minus, the sign will change. That's why we make it this way. That's why we make the opposite sign here, opposite sign here, opposite sign here, because finally I'm going to send them through negative. Which means, by the way, which means if you want, or if you put this value as a positive, if you put this terminal here positive, you are allowed to make this one minus, this one plus, and this one minus. I hope you catch my point. Now, okay, now we reach to this point. So you see, step after step, the things is getting simpler for us. So I reached to a point where this arrangement here is feedback. It's very clear that it's feedback. So we are going to find its result. What is its result? It's going to be equal to G3 into G2 over 1 plus, because this is minus, so here plus, G2 or G3 into G2 into this block, into H1 plus minus H2 plus H3. So this all going to be whatever inside this block. After I do this, the system going to look like this. The system going to look like a block, which is going to be this one, and another block here, which is going to be G1. So that's how the system going to look like. So it's very clear that they are cascade. You multiply them and you are going to get this result. Another example on a block diagram reduction, but here he is putting a value for the transfer function. He putting value so that we can simplify it. We have a chance to deal with it mathematically. He's saying find the transfer function C over R, CS over RS, the output over the input. I want the transfer function, which means we need to reduce the system to one block. When I say the transfer function needed here, it means I need to reduce this to one block. How am I going to deal with it? Let's see here. Before I go to the answer, let us look at it together. If you look at S1 and S2, they are cascade, which means I can replace them by one block. These two can be replaced by one block, which having a value of S square. Fine. Now, after finishing that part, look at this arrangement. Look at this arrangement. We are having signal going to this side, and the signal will meet again at the summing junction. That means it's parallel, which means this green box can be written as S square plus 1 over S. So once we do it, you can you can continue the same way, or maybe you can reflect this one inside. That's what he's going to do afterward. This one reflect it inside, so that you can reduce the steps you are dealing with. You are not going to deal with many steps. Let us see how it's done in the next slide. As you are simplifying, by the way, the circuit will look easier to you. I will tell you two ways in dealing with this system. Let us see how. So notice this is what I mentioned just now. This one, it's fine. Now notice that I have 1 over S here at this location. You have two choices here. You can consider this as a feedback and the result to be cascaded with 1 over S. The result will be feeded back with this one. But this is, you are doing many feedback. Usually feedback is having high chance for error. That's why we don't do it that much unless we have no choice. What is the other solution? He said take this one inside. How to take this one inside? What's the meaning of taking this one inside? If you look at it carefully, you are going to find that here we are having a pick-off point with input and output, another output. So I want to send the block from the output of pick-off point to the input of pick-off point. What is the rule? The rule is saying if you move a block from output of pick-off point to the input, the other output supposed to take the reciprocal, means 1 over the value. So if I do so, I'm going to find that 1 over S will come here. You see, when I move this one to this point, to this location, it's going to be as you see here. And the other branch here, this branch, will take the reciprocal of this value, means 1 over this value. 1 over S is equal to S. That's why we put S here. So now the shape of the signals, or the shape of the block diagram, is as you see here. Now if I want to reduce it, and I have to reduce it, what can I do? Let's look at this signal with this signal. You will find that they are taken from the same point and going to summing junction. That means S with S are parallel. So we can add them together. Let's see in the next slide how he did it. So here he did it same way. You see, he add those two, S and S, it becomes 2S. And the signal or the system looks like this now. It's very clear that it's the remaining is just a feedback as you see here. So this block with this block can be joined together with consideration for the feedback rule as you see here. So substitute the values, reduce, further reduce, and finally this is the transfer function we are looking for. So another example on the calculation of transfer function or reducing the block diagram, where in this system he's asking us to calculate CS over RS. The block arrangement in between looks complicated or more complicated than the other systems before, but if we handle it step by step, we should have no problem in dealing with it. How am I going to deal with the system? Whenever you see such a system, first of all, think of cascade. Is there any cascade? Do it. If there is no cascade, or after that, think of feedback. Is there any feedback? Do it. Then parallel, do it. If you find none of them there, or if you finish all these work, but the system is not finalized, means you have to move a block. What do I mean by this? Let us check. When I look at the system carefully, I will find that this arrangement here is feedback, which can be written as G3 over 1 plus G3 H3, and the result will go to the summing junction, which is going to be, as you see, this part. Now I'm getting this signal. Let me make it the same color. This signal is this signal, and this signal is this signal. Finish now. Let us proceed. What else I can do now? Remember that this is this one here, this one. Don't think it's parallel. It's not parallel because we are having signal here breaking the parallel. So this is not parallel. One more thing. Maybe you will say that this is a feedback. This is not feedback. Remember, this is not feedback. Why? Because of this signal leaving from here. Now, okay, let us find any other thing. Any other thing can be done? There is nothing. I cannot do anything. So it seems to me I have no choice but to move a block. So what, or how can I move a block? Maybe we can take G2 to this location here. If I make it to this location, that means this line will become, let me put it in different color, will become like this. So if I do it, I will find that we will find parallel and feedback done. So if I do it, I will be able to continue with that. Let me proceed in the next slide. So notice here, the block just now I mentioned, G2. G2 was here at this location, and he moved it to this location. What is here? It's a pick-off point. This is the output of pick-off point. Pick-off point output, we send it to the input. So the other output will take the reciprocal. So it take 1 over G1. Fine. Now, if you look carefully at the signal, you will find that this signal with this signal is parallel. Why? Keep in your mind that this is the same node. Same node. There is no difference between this point and this point. If you want to feel better, or if it gives you better feeling, you can put it this way, for example. It's the same thing. So when it's like this, it's very clear that it's summing or parallel. And in the same time, look at this one here. It's feedback. So now I can say that this part is to be taken as parallel, which equal to 1 over G plus 1. Here it's 1. Any empty signal is considered as a 1. With this one, this part is going to be feedback. So once you do them, the system will look easier. What he did here, look, he take this one and he put it here, it's fine, but he didn't do the feedback yet. What he did, he take this one in. It was at the output here, because as I told you, to reduce the number of steps, sometimes we do the feedback, but you have the choice. You have the choice. You can do it as this one first, the result cascaded with this one, the result feedback with this one. You have the choice to do it. Or as he is doing here, what he is doing, he take the G1 to inside. How to describe this? The block G1 was at the input of summing junction. We will send it to the output of summing junction. If I do so, I have to give G1 reciprocal, I mean the reciprocal of G1, supposed to be given to the other input. That's why here we have 1 over G1, as you see here. It's in the denominator, 1 over G1, and here we have G1. Now things getting simpler. Why getting simpler? Because here I'm having this summing junction, these two summing junction, we can join them as a 1. So if I join them as a 1, I will find that this block with this block parallel. When we parallel them, the result will be fed back with this. See the next slide. So here is the cascade of what he did of those blocks. It was very clear. Then he applied the parallel rule to these two blocks, and it results in feedback. As you see here, the feedback is simplified to have this block. Now we have this block and this block are cascaded. As you see here, this one and this one cascaded. It will result on this block, which is going to be the result of the whole question. Okay, dears, that's it for the block diagram reduction. I hope it's clear. I wish you all the best. Thank you.